understand chemical properties of alkenes. Alkenes are the rich source of loosely held pi electrons, due to which they show addition reactions in which the electrophiles add on to the carbon-carbon double bond to form the addition products. Addition of dihydrogen. Consider the reaction CS2 double bond CS2 plus H2 in presence of nickel catalyst gives CS3 single bond CS3, that is ethane. Dihydrogen gas adds to alkenes and alkynes in the presence of finely divided catalysts like platinum, palladium or nickel to form alkanes. This process is called hydrogenation. You can see here the addition of dihydrogen. The second reaction is addition of halogens. Halogens like bromine or chlorine add up to alkene to form vicinal dihalides. Consider the reaction CS2 double bond CS2 plus Br2 in presence of CCl4 gives CS2Br single bond CS2Br, known as 1,2 dibromoethane. And also the reaction CS3 single bond CH double bond CS2 plus chlorine in CCl4 gives CS3 single bond CHCl single bond CS2Cl, which is known as 1,2 dichloropropane. The third reaction is addition of hydrogen halides. Hydrogen halides, that is HCl, HBr, Hi, add up to alkenes to form alkyl halides. The order of reactivity of the hydrogen halides is Hi greater than HBr greater than HCl. Addition reaction of HBr to symmetrical alkenes. Addition reactions of HBr to symmetrical alkenes takes place by electrophilic addition mechanism. Consider the reaction CS2 double bond CS2 plus HBr gives CS3 double bond CS2 single bond Br. And also the reaction CS3 single bond CH double bond CH single bond CH3 plus HBr gives CS3 single bond CS2 single bond CHBr single bond CH3. Addition reaction of HBr to unsymmetrical alkenes, that is Markovnikov rule. How will HBr add to propene? The two possible products are 1 and 2. Consider the reaction CS3 single bond CH double bond CS2 plus HBr can give CS3 single bond CHBr single bond CS3, that is 2-bromopropane, or CS3CS2CS2Br, that is 1-bromopropane. Thus, according to Markovnikov rule, product 1, that is 2-bromopropane, is expected. In actual practice, this is the principal product of the reaction. Hydrogen bromide provides an electrophile, that is H+, which attacks the double bond to form carbocation. Consider the reaction CS3 single bond CH double bond CS2 plus HBr on attack of electrophile gives CS3 single bond CS2 single bond CS2 plus Br minus, and also CS3 single bond CH plus single bond CS3 plus Br minus. While A is less stable primary carbocation and B is more stable secondary carbocation, the carbocation B is attacked by Br minus ion to form the product CS3 single bond CHBr CS3, that is 2-bromopropane, that is major product. Anti-Markovnikov addition or peroxide effect or Kharash effect. Reaction 1. Reaction 1 is CS3 single bond CH double bond CS2 plus HBr gives, in presence of C6H5OO whole twice, CS3 single bond CS2 single bond CS2Br. This happens only with HBr but not with HCl and HI. Addition of sulfuric acid. Cold concentrated sulfuric acid adds to alkene in accordance with Markovnikov rule to form alkyl hydrogen sulfate by the electrophilic addition reaction. Mechanism. The mechanism of the reaction is CS2 double bond CS2 plus H2SO4 gives CS3 single bond CS2 single bond OSO2OH or C2H5HSO4. CS3 single bond CH double bond CS2 plus H2SO4 gives CS3 single bond CH single bond OSO2OH single bond CS3, which is known as propyl hydrogen sulfate. Addition of water. With few drops of concentrated sulfuric acid, alkenes react with water to form alcohols in accordance with the Markovnikov rule. Consider the reaction CS3 single bond C single bond CS3 double bond CS2 plus H2O in presence of H plus gives CCS3 whole thrice single bond OH, which is known as 2-methyl propane 2-ol. Oxidation. Alkenes on reaction with cold dilute aqueous solution of potassium permanganate, that is Bayer's reagent, produce vicinal glycols. Decolorization of KMnO4 solution is used as a test for unsaturation. Consider the reaction CS2 double bond CH plus H2O plus O in presence of dilute KMnO4 at 273 Kelvin gives CS2OH single bond CS2OH, that is ethane 1,2 diol, that is glycol. And also the reaction CS3 single bond CH double bond CS2 plus H2O plus O in presence of dilute KMnO4 at 273 Kelvin gives CS3CHOH single bond CS2OH, that is propane 1,2 diol. Ozonolysis. Ozonolysis of alkenes involves the addition of ozone molecule to alkene to form ozonide, and then cleavage of the ozonide by ZnH2O to smaller molecules. This reaction is highly useful in detecting the position of the double bond in alkenes or other unsaturated compounds. For example, the reaction CS3CH double bond CH2 plus O3 gives CS3 single bond CH single bond O single bond O single bond CS2 single bond O single bond CH, that is propene ozonide, which in presence of Zn in H2O gives CS3CHO plus HCHO. And also the reaction CCS3 whole twice double bond CS2 plus O3, then Zn in H2O gives CCS3 whole twice double bond O plus HCHO. Polymerization. A polymer is a large molecule, that is macromolecule, composed of repeating structural units typically connected by covalent chemical bonds. The large molecule thus obtained are called polymers. This reaction is known as polymerization. Consider the reaction N times of CS2 double bond CS2 in presence of high temperature and pressure condition, and also the catalyst gives CS2 single bond CS2 whole N, that is polythene, and also the reaction N times CH3 single bond CH double bond CS2 at high temperature and pressure condition, and also the catalyst gives CH3 single bond CS2 whole N, that is polypropene.